Hello guys, it's Kene once again. Right, today I will be showing you how to solve a problem in Python, and that problem involves using recursion. Now it's a bit technical, talking about recursion, but I'll just try to explain it the best I can, right? Now what's the question? Write a recursive function to compute the value of the factorial of integer n. So that could be um, factorial of 5, factorial of 6, so 6 factorial or 5 factorial. It all depends. Now, what is recursion, guys? Because we're going to solve this problem using recursion in Python. What is recursion? I would explain it or define it as this. It entails defining something in terms of itself. It entails defining something in terms of itself. Now, what does that mean? You want to explain something, you want to show something, you use the thing repeatedly to explain the thing. Now, that may not make sense yet, right? But with further explanation, I believe you begin to see the sense in it. Now, in Python, recursion is achieved by means of a recursive function. The question is, what is a recursive function? Simple, a function that calls itself. A function is like a block of code that is meant to do something. So, like there's a series of instructions within that block, and the end result is like a particular thing or a set of outputs, right? That's a function. Now, a recursive function is one that calls itself until it gets to a point where it can no longer call itself, right? So let's see a use case of this recursive function in Python. Now, suppose we want to, given the question that we have, get the factorial of 3. So 3 factorial. That will require using a recursive function. But let's see, guys, to break it down. So it's going to start off with the function, and 3 is given as the argument because I want to find the factorial of 3. So 3 factorial. So it takes 3. Now, first call with 3. Guys, if you remember, 3 factorial is actually 3 multiplied by 2 multiplied by 1. We taught that in school. That's 3 factorial. And that actually gives us 6, right? Great. So taking 3, I make the first call with 3, right? So break it down. 3 factorial will simply be equal to 3 multiplied by 2 factorial. Because we know that 2 factorial is actually 2 multiplied by 1. So I want to take the numbers one after the other. So I need to decompose that problem, right? Then, what is 2 factorial? Since I know that getting 3 factorial will require using 2 factorial, then I need to know what 2 factorial is. Now, 2 factorial is simply 2 multiplied by, now, if there's anything like that, guys, multiply by 1 factorial. Of course, 1 factorial is 1. All right, I just, for the purpose of explaining this so that we really get it. Then, since I know that to get 2 factorial, I'm going to need 1 factorial, right? So I need to break it down further. So what's 1 factorial? Now, 1 factorial does not actually need any getting any factorial. 1 factorial is actually 1. So when I get to 1 factorial, I know that it's simply 1, right? So remember that at this point, guys, I am not using any factorial anymore. Okay, I'm not using any factorial. Once I get to 1 factorial, we simply have 1 there. So no factorial anymore. So you see the way I've broken it down. So it goes from 3 to 2. That's 3 times 2, and then times 1. Everything gives us 6. So that's how it's broken down. So 3 factorial is 3 multiplied by 2 factorial. That's the second call with 2 this time. So I want you to observe the reduction. So it goes from 3, and the next time I'm using the factorial function, that is a recursive function in this case. The number is decreased by 1. So 3 goes to 2. So 3 multiplied by 2 factorial. Then it makes yet another call to itself. It calls itself, right? This time it is factorial of 1. But since we know that 2 factorial is 2 multiplied by 1 factorial, everything now gives us 3 times 2 times 1 factorial. That's the third call. And there's like backtracking now. It now starts from the last one, the very last call that was made, right? So that third call is resolved and returned 3 times 2 times 1. Now we see that for us to get to 3 times 2 times 1, then we have 3 multiplied by 2, right? And what is 3 multiplied by 2? Then that brings us to the first call, that is like, you see how we have 3 factorial, which is resolved to evaluated to 6. Yeah, so I know it's a technical concept, but we see how we go from 3 2 factorial to 3 times 2 times 1 factorial to 3 times 2 times 1, right? And then from there, we return to 6 following this procedure or this process. So enough of the talk now. Let's try to now write a Python program to help us solve this problem. Okay, right. So I'm going to do this now. Now, when we are building a recursive function, there are 2 things we need to take note of. The first is the composition of that problem. You see how in getting 3 factorial, we went 3 multiplied by 2 factorial, and then 3 multiplied by 2 multiplied by 1 factorial. So there was this reduction from 3 to 2. Then I called factorial using 2 as the argument. Then the next time I need to call the factorial function, I have 1 as the argument. So it reduces progressively like that. So that's the recursive part, right? That's the recursive part. Then we need to also establish a base condition, because if we keep reaching the recursive part, that is calling the function repeatedly, then it's never going to end. So there has to be a point where the function can no longer call itself. And if you look at the example given here, we see that it is at this point when we get to 1, right? At that point, nothing else. So 1 factorial is actually 1. So it reaches 1, and there's no need to get factorial of 1. I don't need to call the factorial method again. I just know that 1 is going to, factorial of 1 is 1. So reaching 1 in the case of this particular problem, reaching 1, that point where we have 1, that's the base condition there for this recursive function, right? So those are the 2 things, the 2 parts. The recursive part, where the recursive function has to call itself, and the base condition where we've reached a point where there's no need to call that function again. So let's see in this case now. I'm going to define a function. The fact, let me just call it f, which is factorial. And I'm going to give it this value of n, right? So n is like, say, 6 factorial, the number which I want to, use in computing a factorial value. So def fn. Now I need to, for a start, it's not going to use until the very last, should I say, iteration at, that point. But I'm going to just define it here. But it's not going to run until it has considered the other recursive parts. So I'm going to say if n equal to 1, because 1 factorial is 1. So I want the program to just return 1. If n equals to 1, my program should return 1. Now, else, now what do I want? I need it to return n multiplied by, now I'm going to call this function recursively. Then it is going to, you know how we had, if n were 3, then 3 factorial will be 3 multiplied by 2 factorial. So I'm going to call the factorial method function again. But this time, what will be the argument will be whatever was supplied as n minus 1. So it goes from 3 times 2 times 1, so reducing by 1 progressively. And that's all we need to do. Then at the end of it all, guys, I am going to simply print my function there and give it 3 as the argument. Simple. So let's see, guys. Run the program, and that's fact 6. Beautiful. Isn't that just lovely, right? So you can have any number, let's say 5 factorial 120. So we can see, let's even test it. 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So 5 times 4, 20, 20 times 3, 60, 60 times 2, 120, 120 times 1, 120. So 5 factorial is 120. So that was right. And let's see what 6 factorial will be. So that, since I have 120 as 5 factorial, 6 factorial will be 6 times 5 factorial. Since I already know what 5 factorial is, which is 120, so I'll just say 6 multiplied by 120. So 6 factorial should be 6 multiplied by 120. We'll see what that gives us. 720. So 6 factorial is 720. So guys, that's how you use recursion in calculating the factorial of a number, right? I hope we learned something. Now, I need to say this, before I end this video. It is not really advisable to use recursion because it has some drawbacks. It might be useful, in the sense that, it makes your program easy to read. It looks good on the screen. But it actually makes it difficult to debug your program. It makes it difficult to identify, errors at the end of the day, where you have a very long, many lines of code. That could be a problem with using recursion. Secondly, it is not good on your computer's memory. Not good at all, because it uses a lot of resources. It uses a lot of memory, because it needs to keep storing what is returned and then eventually backtracks to output everything that it had stored. So that's the thing about recursion. And so you can imagine when it has to store 3 multiplied by factorial, 2 factorial, it stores that. Then it comes again and stores 3 multiplied by 2 multiplied by 1 factorial, it stores that, and then it goes from there again collect all to output the final thing. So that's a lot of work, and it requires a lot of memory. You don't want to use recursion in every instance. Okay. All right, guys. Thank you so much for listening, and it was great solving this problem. This problem using recursion. Remember, this is the problem. Write a recursive function to compute the value of the factorial of integer n. I'll see you guys in my next video. Do have a wonderful day. Bye.